Good morning, students. Now we can see about the Bio-Zoology, Chapter 12, Environmental Issues Continuation. The last two classes we have seen about air pollution and water pollution in detail. Now we can see integrated wastewater management, that's treating the wastewater. How we are going to treat the wastewater in a useful way. See, wastewater treatment can be carried out in three ways. One of the method is physical method, next chemical methods, and then biological methods. Then physical methods, you know very well that actually physically we are treating the water. That means what? What type of water can be treated by physical method? That is, if the water is having coarse impurities, coarse the big size particles, that's sedimentable particles. Like that, if we have, that can be easily removed by flotation, even by hand picking also. Then flotation, sedimentation, filtration and centrifugal separation, etc. So on, so on. See, these are the different ways of removing the physical impurities. That's the coarse particles. If water is having coarse particles, that can be removed by such methods. Now, next one is a chemical method of wastewater treatment, and that can be that includes what generation of insoluble solids, produce an insoluble gas, then produce biodegradable substance from the non-degradable substance. So now we can see one by one. See, actually generation of insoluble solids. How can it generate insoluble solids? If the impurities be as colloidal solution, as a miscible particles are there, and non-settlable. So if the water is having such impurities, that can be removed by converting that into some insoluble solids. That's by adding some chemicals that can be coagulated, may settle at the bottom, that can be removed easily. Then another one is by producing insoluble gas. See, that's oxidizable impurities. If it is able to convert into gas, such thing can be removed as gas by adding some chemicals. That is what you call as producing an insoluble gas. Now, next one is what produce biodegradable substance from non-biodegradable substances. See, and non-biodegradable cannot be degraded by microorganisms. That can be easily converted into another form that can be easily degraded by microorganisms. That is what you are telling here as converting or producing biodegradable substance from non-biodegradable substances. That all these things will involve addition of chemicals. Now, next one is biological methods of wastewater treatment. That is what bioremediation and phytoremediation. See, bioremediation that includes aerobic treatment as well as anaerobic treatment. See, aerobic treatment means we are treating the water in the presence of oxygen. Anaerobic means the absence of oxygen. Then phytoremediation that includes constructed wetlands, root zone wastewater treatment and decentralized wastewater treatment system. So these systems will come under phytoremediation. That's a process is given below. See, you can see in these pictures. Now, next topic we can see organic farming and its implementations. So, what is organic farming? So, it is a method of farming system which aims at cultivating the land and raising crops to keep the soil alive and for increased sustainable production in an eco-friendly, pollution-free environment. See, eco-friendly, pollution-free environment means by producing production of crops in an eco-friendly way. We are using lot of systems, but that is not a polluting the environment. That is what we call as eco-friendly, environmentally friendly. Then soil waste management. See, you know very well every day tons of soil waste are disposed of the land side. The land side, so there's a lot of tons of waste are disposed. See, this waste comes from homes, offices, industries, and etc. So and so. See, these landfill sites produce foul smell if waste is not stored and treated properly. So, if it is left as such, what will happen? See, if you go through that way, that foul smell will come because of the degradation of this water materials. See, so if you are not treating that one and disposed in a proper way, that will pollute the environment to large extent. Again, when you have hazardous waste like pesticides, batteries contain lead. Lead is highly dangerous to our health. It is highly carcinogenic. Then cadmium, mercury, cleansing agents. These things are mixed with this waste with the paper and other these things, they produce gases like dioxin. That's especially plastics on burning. Degradation will give the toxic gas, that is what poisons as dioxin, highly dangerous. These gases are toxic and carcinogenic. They pollute the surrounding air, groundwater, and can seriously affect the health of humans, wildlife, and our environment. So our environment will be highly polluted. See, these are the main sources of some salt waste. This is shown the tabular column. See, residential, industrial, commercial, institutional, construction, demolition. There's agricultural waste, then biomedical waste, e-waste, etc. These are some of the sources of this water salt waste. Then salt waste management. So, how we are going to manage this salt waste? See, salt waste management, this includes the activities and actions required to manage waste from its inception to its final disposal. See, before disposing the waste, we got to treat that in a proper way. So, by converting this toxic materials into non-toxic materials, then only we got to dispose the waste in the land as well as the air or the water. So, if you are following this in a proper way, the environment will be protected from pollution. Then, this includes the salt waste management includes the collection, transport, treatment and disposal of waste together with the monitoring and the regulation of the waste management process. So, what is the meaning of it? See, collection. What is the meaning of collection? See, you know very well the waste. People are collecting waste from different places, from the residents or industries or the hotels and all. See, first that includes collection. First collecting the waste. Transporting. They are taken by that's four-wheeler, vehicles, then big vehicles they are using. See, that is what is transporting. That's transportation, transporting this waste. Then treatment. Then after transporting, you are collecting all this waste in a proper place. Then you are following the treatment. Treating the waste. You are converting that into useful product. Okay. Then and also main thing, we are removing the toxic impurities from it. Okay. Then after that, disposal of the waste. So these steps you have to follow. So, in between that, you have to do monitoring and regulation of the waste management process. So, whether they are following the process properly or not. So, monitoring is also. So, for every action, we need monitoring. So, if you are monitoring everything properly, everything will be correct. Like that here also. So, first thing is the salt waste management. The different steps involved: first collection, then transporting, that one taking to some area, then treating that one, and then disposing the waste. Together with the monitoring and regulation of the waste management process. It is also about how salt waste can be changed and used as a valuable resource. So, under salt waste management, this also will be included as a theme, how the salt waste can be changed and used as a valuable resource. So, after converting the salt waste into useful product, that is highly useful. Can be used as fertilizer or some other purpose also we can use it. Okay, so that's under the salt waste management, this will also be included. That is how the salt waste can be changed and used as valuable resource. Okay, then waste management practices. See, under waste management practices, we are seeing these topics is source segregation, composting. Composting is actually aerobic and anaerobic. Vermicomposting, then biogas generation, incineration. Incineration is nothing but incineration is nothing but burning. Then biogas, that's biogas generation means from the waste we can get biogas. See, you can use this gas for cooking and all. Okay, then vermicomposting. That's by this you are getting some useful, converting into useful fertilizer. Okay, so these are some of the steps followed in some of the waste management practices. Okay, in all these practices, we are converting the waste in a useful way. Okay, then next one we can see radioactive waste. It is highly dangerous waste. And see, radioactive waste are they generated during various operations of the nuclear power plant. You know very well the nuclear power plant we are using highly dangerous radioactive materials. That cannot be degraded, will continuously emit radiation, highly dangerous one. Okay, so this disposal of this waste should be when disposing this waste we should be very careful. Okay, so radioactive waste are generated during the various operations of the nuclear power plant. Our nearby nuclear power plant is at Kalpakam. You know very well, isn't it? See, then next one, radioactive waste management. See, how you have to dispose this waste. Since radioactive waste management involves a treatment, storage, and disposal of the liquid, airborne and solid effluents from the nuclear industry. So, these things should be properly treated and disposed. Then methods of disposal of radioactive waste involves limit generation. What is limit generation? See, if you use very pure raw material, so quantity of the waste formed can be limited. That is actually limit generation. So pure, 100% pure starting material, if you are using the raw material, if you used is a very pure, quantity of the waste generated will be minimized. That is limit generation. Okay. See, dilute and dispose. What is meaning? So there is a highly concentrated waste is there, means dilute. The content concentration should be reduced, and then you have to dispose. Then delay and delay. Delay and delay. 9. Very short-lived radioactivity. That means what? Actually, that's a delay and decay. Delay and decay means what is actually a delay and decay. See, very short-lived radioactivity. What's the meaning? See, very short-lived radioactivity means, see, most of the radioactive elements are long-lived only. Will continuously emit radiation. So there can be, by certain process, we can convert that into some short-lived radioactive material. That is one of the way. Okay, then concentrate and confined process, long-lived radioactivity. See, actually our aim is to reduce the long radioactivity. We can reduce this lifetime of this radioactive elements. Then medical waste. And then next topic you can see medical waste. What is medical waste? You know very well. Actually, the waste generated from the hospitals or laboratories, like that. See, any kind of waste that contains infectious materials generated by hospitals, laboratories, medical research centers, pharmaceutical companies, and veterinary clinics are called as medical waste. Anyway, the hospital area. Okay, see, you know very well these waste contain lot of what microorganisms will be there, highly toxic one, that one. So, safe disposal is highly essential. So, waste disposal, how can we dispose these waste? One is incineration. Incineration is nothing but burning, proper burning. After burning only we have to dispose the waste. Then chemical disinfection. By using some chemicals, so infectious things can be removed. And autoclaving, this is also a type of heating decorates. The encapsulation, actually by packing in something, you are disposing in a proper way. Microwave irradiation. So microwave irradiation, if you irradiate this by microwave, so the microorganisms, some toxic things can be damaged, removed. Then landfill. Landfill means what you are taking some pit, you are dumping the waste, then filling by soil. Okay, that's landfilling. Landfilling also different methods are there. So we are telling about what landfilling. That's simply filling it by soil. Okay. Then next one we can see e-waste. E-waste is nothing but electronic waste. So these are the main source of e-waste. See, you can see the picture types of e-waste. See, mainly from the computer, computers waste, and then electrical electronic goods. These things. Okay, see, we can see some of the sources: scanners, printers, keyboard, mouse, and other electronic devices, cell phones, and tablets. Then audio, video equipments, television, monitor, and laptops, personal electronic devices. All these things will generate electronic waste or e-waste. In short, we can tell it as e-waste. Electronic waste or e-waste is a discarded electronic, electrical and electronic devices. So in short, you can tell and define like this. This is nothing but discarded electrical and electronic devices. So e-waste are basically polychlorinated biphenyl based PCB. In short, we can tell PCB, that's nothing but polychlorinated biphenyl. So these waste mainly contain this chemical PCB base, which are non-degradable. That's the main thing you have to notice here. This is highly this is not biodegradable, non-degradable. So unauthorized processing e-waste can lead to adverse human health effect and environmental pollution. So, see, if you are simply disposing such waste, that will cause environmental pollution and also it will affect the human health. Okay, so there is a safe disposal is highly essential. Okay, then natural plastic waste and solutions and remedies. Plastic waste, already I told you, burning of plastic will give a toxic gas dioxin, highly dangerous, will affect the human health. Okay, and this the living organisms will also be affected. Okay, now we can see plastic waste is solution and remedies. So plastics are now low molecular weight organic polymers. So plastics are nothing but polymers that non-degradable in natural environment. So in the natural environment, if you dispose it, non-degradable, it will be as it is. Okay, see. So plastic waste constitute a major part of municipal solid waste. So under the municipal solid waste, the major role is plastic waste because it is non-degradable. Remedies. For the remedy of this one, we can in the olden days we can use 3R principle. Nowadays it is modified as 4R principle. So 3R means reduce, reuse, recycle. But here we are adding one more thing, refuse. So 4R principle, that is a refuse, reduce, reuse and recycle. So mantra is a mantra, 4R principle, one mantra we are using. What is the mantra? 4R principle, and nothing but refuse, reduce, reuse and recycle. It's the best available remedy for plastic waste pollution. Okay, see, preventing the usage, reduce the usage, then reuse. See, example, see some plastic containers you are getting, you are using that's something you are stored in a plastic container. After using it up, but it will be empty. Don't dispose it as it is in the land. See, we can reuse it. You can reuse it for filling refinery, some acid like that. Then recycle. We can instead of disposing that one, we can recycle, melt and remold. That's recycling process we can follow. Okay, so by using 4R principle, we can rectify this pollution caused by the plastics. Okay, now we can see global environmental change. These topics already the previous class was we have seen. Anyway, now somewhat in detailed form we can see here. First one, very important question also, greenhouse effect and global warming. See, what is greenhouse effect? See, the progressive warming of Earth's surface due to blanketing effect of man-made greenhouse gases is called as greenhouse effect. See, what is blanketing? Here, the ozone layer is acting as an umbrella for us. This is screening us from the harmful UV rays coming from the sun. Okay, so this blanket, our umbrella, is now depleted because of our activities only, man-made activities. Because we are using refrigerators, we are doing deforestation, cutting the trees and using the land for constructing buildings and all. Okay, so because of these reasons, what is happening? See, these gases, carbon dioxide, methane, nitrous oxide, CFC is chlorofluorocarbons. So these things are highly concentrated in the environment. So these gases will deplete the ozone layer, our blanket will be depleted. Okay, so because of this, what is happening? UV rays are directly coming to the earth, it is affecting. See this picture. See, because of this blanketing greenhouse effect, what is happening? This will be the thinning of the ozone layer will occur. So see, solar rays are directly coming to the earth. So UV rays, how much it is harmful, you know very well, highly harmful, carcinogenic. Okay, so because of this greenhouse effect, what is happening? The increased input of carbon dioxide and other greenhouse gases in the atmosphere will enhance the Earth's natural greenhouse effect. It's rise in the average global temperature. So global warming, the main reason is ozone depletion. See, because of greenhouse gases. So again, then see, because of carbon dioxide concentration in the atmosphere, the temperature will be increased. Okay, increased. That is causing global warming. So what are the effects of global warming? See, if the temperature is increased, but in the polar region, the icebergs will be melted. So rise in the sea level. causing, so because of this what will happen, causing drought and flood. Then the submergence of land, increase in waterborne diseases, affect agriculture and crop production, affect terrestrial ecosystem. Okay.